Okay, so let's consider one of the easiest, in my opinion, one of the easiest examples, yes, of the redox reactions. You could see the zinc reaction with hydrochloric acid, and we obtain zinc chloride salt and hydrogen particle. Yes. Okay, this is electrochemical reaction. This is redox reaction. As in the case of every single reaction, we have products and substrates. The reaction proceeds from left to right. On the left side of the arrow, we have substrates. On the right side of the arrow, we have products. This is redox reaction. So, in this reaction, there are oxidation and reduction reaction. Our task, firstly, is to find elements which are included in the presented compounds or elements that stand alone, which change their oxidation state during the reaction. Okay, so we must to find oxidation reaction, so it is the increase of oxidation state, and we need to find reduction reaction, so the decrease of oxidation state. Okay, so let's check it step by step. Starting, of course, from the substrates. Firstly, zinc. This is atom of zinc. It's metallic zinc. The oxidation state of one metallic atom of zinc is equal to 0. Okay, so let's find the zinc on the side of the products. So on the right side of the arrow. Here we have a zinc which is included in the particle, yes, in the zinc chloride salt. In this particle, zinc oxidation state is equal to +2 because chlorine ion is equal to -1. We have two chlorine ions which give us -2. Therefore, zinc oxidation state is equal to +2. Okay, so you could see that we found element that undergoes oxidation reaction. So zinc increase his oxidation state from 0 to +2. Okay, as we know, if there is oxidation reaction, it also should be reduction reaction. As I said to you, that none of this reaction proceeds alone. If there is oxidation, it also appear reduction reaction. Both of them proceed always together. So let's check the next element, hydrogen. In hydrochloric acid, hydrogen oxidation state is equal to +1. Okay, let's find hydrogen on the right side of the reaction. Here, okay, hydrogen particle. In the hydrogen particle, we have two atoms of hydrogen. Every single atom oxidation state is equal to 0. So we can see the change of oxidation state from +1 to 0. It means that hydrogen also changed his oxidation state from +1 to 0. It means that hydrogen undergoes reduction reaction. Okay, let's check for sure chlorine. Chlorine in hydrochloric acid oxidation state is equal to -1. We found chloride in zinc chloride compound. In this compound, chlorine oxidation state is equal to -1. So there is no change of oxidation state of chlorine atom. Okay, so we know that zinc and hydrogen undergoes redox reaction. And now I will show you in this example and the next one, so the easiest examples, I will show you only one method of filling the stoichiometrical coefficients in redox reaction. Yes, let's see. Um, let's see what we got: oxidation of zinc and reduction of hydrogen. Okay. So what is the next step? In the next step, we need to write every single redox reaction, I mean oxidation and reduction, in separate step. We need to write it alone. So firstly, oxidation reaction. We know that oxidation reaction undergoes zinc, yes, from metallic state to zinc cation. Yes, zinc cation. This reaction is very important. This reaction proceeds in aqueous electrolyte solution. Aqueous means containing water particles. Yes, in this solution, hydrochloric acid and zinc chloride are in the form of ions. They undergo dissociation. Yes, so they exist in the form of ions. So zinc metallic to zinc cation with the charge equal to 2 plus. So of course we need to write also 2 electrons because this atom of zinc, metallic zinc, lose these 2 electrons. Why? So the cation is created. Okay, so let's write the redox reaction. We have H plus and we obtain particle of hydrogen. Yes, and already at this step we need to fill stoichiometrical coefficient. So we need to make matter balance, the balance of matter. Yes, on the right side we have 2 atoms of hydrogen which are included in one particle. So on the left side we need to write 2 in the front of hydrogen cations. So we need to use 2 hydrogen cations. Okay, this is a reduction reaction. So hydrogen cations gain hydrogen cations. I'm sorry, I will proper it. Okay, hydrogen cations gain 2 electrons. Okay, those are the same electrons which appear in the oxidation reaction. So the 2 electrons which are created in the oxidation reaction are consumed in the reduction reaction by 2 cations of hydrogen. So there is a creation of the hydrogen particle. Okay, so let's try to write the overall ionic reaction, the total ionic reaction from these 2 half cell reactions, I mean oxidation and reduction. Okay, so as can you see, in the case of oxidation and reduction, we have substrates which are on the left side of the arrows here, and we have products which are on the right side of the products. Yes, so let's start write it, starting from substrates. zinc metallic, so I mean with the oxidation state equal to 0, plus 2 hydrogen cations plus 2 electrons give us products. In the products we have zinc cation plus 2 electrons plus hydrogen particle. Taking into account the information that these 2 electrons are the same, those are the same electrons that appear in the reduction reaction, we could remove these electrons from the overall reaction. Yes, because taking into account these electrons in this reaction doesn't have any sense here. So the overall reaction looks like this. Atom of zinc plus 2 cations of hydrogen give us atom of cation, not atom, but cation of zinc with the charge equal to +2 and hydrogen particle. And we could fulfill the main particle-like reaction now. Here we have it on the top of this page. Yes, so we have 2 hydrogen cations, so we have to write 2 in the front of hydrochloric acid. Okay, in the front of zinc atom cation and cation as well as hydrogen particle, there are no other numbers, so we don't need to fill anything else. Everything is correct. Yes, let's check the main equation. Yes, the main reaction. On the left side of the arrow, I mean in the substrate, there is 1 atom of zinc. On the right side, also 1 atom of zinc. On the left side, 2 atoms of hydrogen. On the right side, also 2 atoms of hydrogen and 1 hydrogen particle. On the left side, 2 atoms of chlorine. On the right side, also 2 atoms of chloride. Okay, so using this method, let's make another very similar example.